Hey folks, welcome back. In this video we're going to go over one worked example to show you how to do problems involving relay switch circuits. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get started. So in our one and only example, it says a security floodlight is used to automatically illuminate an area outside a building when it gets dark. The circuit for this system is shown below. So here we've got a control circuit linked to a relay switch circuit. And you might remember the parts of the control circuit. We've got the input on the left where the potential divider circuit is. We've got the processing part in the middle where the transistor is. And then the output is this part up here with the relay switch. You'll also see we've got a supply voltage of 5.0 volts. We've got a variable resistor as the upper component at 16.6 kiloohms. We've got an LDR, a light dependent resistor, as the lower component. We've then got an NPN transistor and a relay switch connected to this second circuit, which has a fuse, a floodlight, and an AC supply voltage of 230 volts. It then says the resistance of the variable resistor is set to 16.6 kiloohms, and the transistor in this circuit has a switch-on voltage of 0.7 volts. Part A says the light level decreases to the point where the resistance of the light-dependent resistor is 3.4 kiloohms. Show by calculation that the transistor is switched on at this light level. Well, looking back at the diagram, we're told that this LDR has a resistance of 3.4 kiloohms or 3400 ohms. And in order to show by calculation that this transistor will switch on at this light level, we need to know what the voltage is going to be across this transistor to show that it's greater than or equal to 0.7 volts. And to answer this question, we need to remember a really important rule from control circuits, which is that the voltage across the transistor is equal to the voltage across the lower component. So if we can find what the voltage is across this LDR, then we know what the voltage across the transistor is, and therefore if it's on or off. And to do this, I'm going to use a potential divider equation, because remember, these two resistors in series with a supply voltage is just a potential divider circuit. Remember, we've got two equations on your relationship sheet for potential dividers, and I'm going to use the one here where we know what the supply voltage is, Vs, because we're told that Vs is 5.0 volts, and we know what the two resistances are. So I'm going to start by labeling the lower component as number 1 and the upper component as number 2, but it's up to you which way you want to label these. You could do the opposite. So because I'm trying to find the voltage across resistor R1, I'm going to try and find what V1 is. So writing down what we know from the question, we're trying to find V1. We know that R1 is 3400 ohms, just changing the 3.4 kiloohms into ohms, so timesing by 1000 there. R2 is 16.6 kiloohms, which we can convert into 16,600 ohms. And lastly, the supply voltage Vs is 5.0 volts. So writing down our equation for potential dividers, where we know what the supply voltage is, we have V1 equals R1 over R1 plus R2 times Vs. Substituting in the numbers gives 3,400 divided by 3,400 plus 16,600 times 5.0, and putting all of that into your calculator should give you an answer of 0.85 volts. Now it's good to finish this off with a statement to say that since 0.85 volts is greater than 0.7 volts, the transistor is on. Lastly, part B says the floodlight is connected in a part of the circuit controlled by a relay. Explain why a relay is used in the circuit. Well, looking back at the diagram, we can see that the control circuit is operating at 5.0 volts, whereas the second circuit over here with the floodlight operates at 230 volts. So we could say that the control circuit operates at 5 volts, whereas the floodlight operates at 230 volts. And we could then go on to say that the relay allows the higher voltage circuit to be controlled using the safe lower voltage circuit. And remember, this is the main reason for using a relay switch. It sort of acts as a safety feature. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.